Today we are going to discuss the acceleration analysis of a slider crank mechanism. Okay, so the question is crank OA is equal to 200 mm, connecting rod AB is equal to 600 mm, the distance of the center of the mass of the crank end AD is equal to 200 mm. At the instant, the crank has an angular velocity of 50 radians per second clockwise and an angular acceleration of 800 radians per second square. Calculate the velocity of D and angular velocity of AB, acceleration of D and angular acceleration of AB. Okay, so this is the question. So I hope you have got a basic understanding of how to draw an acceleration diagram. So I'm forwarding with the question. Okay. So for drawing the acceleration diagram, first we have to complete the velocity diagram. Okay, so after completing the velocity diagram, you have to fill the velocity part of the entire table. Okay, so first of all you have to mark the fixed points. Okay, so I'm fixing the points right over here. So this is the point O and G. Okay, O dash, G dash. O dash, G dash, these are the two fixed points. Next you have to calculate centripetal component. Okay, centripetal component and tangential component. So the centripetal component. Okay, so first we are calculating the OA centripetal component. Centripetal component is equal to V square by R, which is equal to the velocity VAO is equal to 10. Okay, V square by R is equal to 10 square by R. R is equal to 0.2, and the value will be equal to 500, right? 500 meter per second square. Okay, so CC, the centripetal component value is 500. So I am taking this much of 500 meter per second square as 5 centimeter for my acceleration diagram. Okay, so in the question it is provided that the angular velocity as 50 radians per second and angular acceleration, that means there is an alpha component for the crank. Okay, so there will be a tangential component. Okay, so tangential component is equal to R alpha, and which is equal to 0.2 into 800 and is equal to 160 meter per second square. Okay, so this is equal to 160 and the value will be 1.6. Scale value will be 1.6 centimeter. So next I am going to draw the centripetal component and tangential component of this particular link OA. For the centripetal component, the direction will be towards the fixed point. So the direction will be like this. Okay, so I am drawing this. Okay, so this is your centripetal component. Okay, centripetal component of OA, and from this point you have to draw the tangential component, and the value of tangential component is 1.6. Okay, so I am drawing this 1.6. Okay, and I'm naming it as tangential component of OA. Okay, now I am joining these 2 points, and this is your vector, acceleration vector, and this is your acceleration vector. Okay, and this point is named as A dash. Okay, this is your point A dash. Now I am going to calculate the acceleration components for the link AB. So the centripetal component is equal to v square by r and is equal to 5.2 square divided by 0.6. Okay, and the value will be equal to 45.1 meter per second square. Okay, so the centripetal component of AB, link AB, is equal to 45.1. Okay, so I am treating this as 0.45. Okay, next component is the tangential component. Right now the value of tangential component is not determined, but the direction is known. Next we are going to plot the centripetal component and tangential component of the link AB. So the direction of the centripetal component will be like this, that means towards the fixed point. Since this is the relative acceleration method, A is assumed to be fixed. Okay, so from here, from A dash, I am going to draw the centripetal component. Okay, so I have drawn the centripetal component, that means centripetal component of link AB. Next I am going to draw the perpendicular, which is the tangential component. So this is the tangential component of link BA. After that I am going to draw the acceleration vector of the slider. So here the slider is moving inside a guide, that means the cylinder, and it will be having only linear acceleration. That means the slider will accelerate like this, either in this direction or in this direction. Okay, the acceleration vector of the slider will pass through the point G, and which is in a horizontal direction. That means the line of action. Here the line of action is in a horizontal direction. So the velocity, the acceleration vector will be like this. So here you got an intersection point, and that point will be the point B dash. Okay, so the point, this will be B dash, and the direction will be like this. And next you have to complete the acceleration diagram by drawing the vector A dash B dash. Okay, okay, next you have to locate the point D, which is in the link AB. So it will be somewhat over here, in between, in the vector A dash and B dash. So for locating the point D, you have to simply take the ratios. That means AB, that means the length AB divided by AD is equal to A dash B dash divided by A dash D dash. Okay, so from this you can find the value of A dash D dash. So I am marking this point as D dash, and I am joining this vector D dash. So I am now I am going to join the points D dash and O dash. Okay, which is the required acceleration. Okay, so upon measuring this value, vector O dash D dash is equal to 3.72 centimeter. Okay, so I am writing it over here, 3.72 centimeter, and the corresponding acceleration value is equal to 372. So in the question it is asked to find out the velocity of D, omega D, omega AB, then acceleration of D and alpha AB. That means the angular acceleration of AB, link AB. Okay, so next what we are going to do is, we have already calculated the value of velocity of d, and that will be equal to 8.8 meter per second, and omega ab is equal to it will be, the value will be equal to by taking this velocity value. Okay, v is equal to r omega, where the value of v is equal to 5.2 and r value is equal to, that means r is equal to 0.6 and v is equal to 5.2. so from this you will be getting omega ab. Okay, and the value of omega ab will be equal to 8.67 radians per second. Okay, next you have to calculate the value of AD. Upon measuring this vector O dash D dash, we can find that it is 3.72 centimeter, and the value will be equal to 372, and alpha AB, that means the angular acceleration of the link AB, so the angular acceleration of the link AB will be obtained from, so you can check that the link AB corresponding there is a velocity. So here you have got centripetal component. The value of centripetal component is v square by r, right? V square by r, and there will be a tangential component, that the value will be equal to r alpha, and this alpha value will be equal to the angular acceleration of the link AB. Okay, so in order to find this alpha value, you have to first measure the corresponding dimension of acceleration diagram. Okay, so what is this particular value? This value corresponds to this vector. Okay, that means the tangential component, that is tangential component of BA. Okay, this is actually that particular value. So upon measuring this dimension corresponding to this tangential component of BA, okay, and the value will be equal to 5.21 centimeters. Okay, and the corresponding tangential component value will be equal to 521 meter per second square. Okay, that means the tangential component of BA is equal to 521, which is equal to r alpha AB. Okay, and the value of r is equal to 0.6. Therefore, the value of alpha AB is equal to 521 divided by 0.6. Okay, 521 divided by 0.6, and the value will be equal to 868.33 radians per second square. Okay, alpha AB is equal to 868.33 radians per second square. Okay, so these are the 4 answers of our questions. Okay, I will explain once again how to draw the acceleration diagram. First of all, mark the fixed points, then draw the centripetal component. That means this is your first vector, this is your first centripetal component. Then draw the tangential component. Okay, then you will be then you have to draw the resultant vector. So this is your resultant vector O1 A1. From the point A1 you have to draw the centripetal component of the link AB. So next you are going to draw this vector. After that you have to draw the vector tangential component, okay, corresponding to the tangential component. After that you have to draw the acceleration vector of the slider. So this is your sixth vector. Okay, then you have to complete the vector A1 B1. This is your seventh vector. After that you have to complete the vector O1 D1. Okay, and this is your 8th vector. Okay, so this is how you have to carry out an acceleration analysis of a slider crank mechanism. So please refer my previous videos for the detailed explanation of an analysis. Please try to solve this question. Thank you.